Welcome back to G Fun Facts Online, where we dive deep into the world's most fascinating facts. Today, we're journeying to a place of immense scale and surprising youth, Hell's Canyon. Nestled along the border of northeastern Oregon and western Idaho, this isn't just any canyon. It's North America's deepest river gorge, plunging an astonishing 8,000 feet. That's nearly 2,000 feet deeper than the Grand Canyon. For over a century, geologists have been captivated by Hell's Canyon, wondering how and when this colossal chasm was carved by the relentless Snake River. Early ideas were mostly speculation, lacking solid proof. But get this, recent, groundbreaking research, using clues hidden in caves, has completely rewritten its story, revealing it's much younger than we ever thought. Now, dating a canyon is tricky. You're essentially trying to date an absence, a giant hole in the ground, where the rock used to be. The direct evidence is often washed away. Previous estimates, based on things like lava flows near the canyon's rim, suggested Hell's Canyon was less than 16 million years old, with some theories proposing the carving started around 6 million years ago. But a new study, published in the prestigious Proceedings of the National Academy of Sciences, has thrown a geological curveball. By meticulously studying ancient river sediments preserved inside caves high above the current Snake River, scientists have pinpointed that Hell's Canyon was rapidly sculpted around 2.1 million years ago. This makes it significantly younger than the Grand Canyon, whose youngest parts are around 5 to 6 million years old. So how did they figure this out? The secret lies in a clever technique called cosmogenic nuclide dating of cave-bound river deposits. Imagine caves, especially limestone ones, as natural time capsules. If a cave forms at river level, it can trap and preserve river sediments. As the river carves deeper, these caves, with their precious cargo of ancient sand and gravel, are left stranded high up on the canyon walls. These deposits, once buried and shielded from cosmic rays, can be dated by looking at the decay rates of certain elements like beryllium-10 and aluminum-26, which are formed when cosmic rays hit rocks. This method tells scientists how long the sediments have been buried, and crucially, when the river was flowing at that specific elevation. This incredible discovery was spearheaded by Matthew Morris, a geologist with the Utah Geological Survey. His team embarked on a challenging hunt for these ancient clues. After initial attempts on the steep canyon walls came up empty, Morris shifted focus to the limestone caves. With the help of local spelunkers, they explored over 30 caves and finally hit the jackpot. Several caves contained the vital river gravel and sand deposits. One key cave was found about 1,200 feet above where the Snake River flows today. The analysis of these cave deposits, combined with looking at the river's profile and using computer models, painted a dramatic picture of Hell's Canyon's birth. The study revealed a major geological event called a drainage capture was the trigger. Around 2.1 million years ago, plus or minus a million years, the landscape shifted dramatically. The Snake River changed its course and connected with the Columbia River system. This likely happened because a massive lake in what's now Idaho overflowed, possibly due to geological shifts and melting glaciers, in what's known as a fill and spill event. This drainage capture massively increased the Snake River's drainage area, and with it, its power. The newly supercharged river began to carve downwards with incredible speed. The rate of incision jumped from about 0.01 millimeters per year to a much faster 0.16 millimeters per year. That's a huge increase. This rapid downcutting also created distinct features called tributary nick points, basically steep drops or waterfalls in the streams that feed into the main river, which decrease in elevation further from where the capture happened, adding more evidence to this drainage capture theory. The researchers concluded that before 2.1 million years ago, there was simply no river canyon in that location. This revised, much younger age for Hell's Canyon is a big deal. It changes how we understand landscape evolution in the region and even globally. It shows how events like drainage capture can be incredibly powerful, carving out gigantic canyons in what is, geologically speaking, a very short amount of time. These findings challenge older ideas about how long it takes for some of Earth's most dramatic features to form, and really highlight just how dynamic river systems can be. Understanding how quickly canyons can form is vital for interpreting regional tectonic history, how sediments are transported, and how aquatic ecosystems evolve. Think about it. The rapid formation of Hell's Canyon would have had huge impacts on fish species, potentially isolating some populations while connecting others. While this study answers a huge question about Hell's Canyon's age, it also opens up exciting new research paths. Scientists believe the canyon still holds many secrets. Future studies could explore the ecological aftermath of the canyon's formation, like looking at the genetic divergence of fish species or how plants and animals adapted to this rapidly changing landscape. Plus, this innovative use of cave records for dating canyon incision is a technique that could be applied to other mysterious canyons around the world, potentially rewriting their geological stories too. So the next time you think of Hell's Canyon, don't picture an ancient relic slowly etched over eons. Instead, see it as a remarkably young and dynamic feature, born from a dramatic geological event and carved with astonishing speed. North America's deepest gorge, once a geological puzzle, now stands as a powerful testament to the Earth-shaping forces that can reshape our planet in the blink of a geological eye, all thanks to the silent stories hidden within its caves. Thanks for tuning in to G Fun Facts Online.